Here we are for our next geometry video lesson. I am moving forward in section 2.1. It's still the same day. My goal was to record 4, but the first 2 today have taken me an hour, and I didn't expect it to take quite that long. But okay, so I'm at least going to get a third one done. I'm not sure if I'm going to do a fourth. So you'll notice the background's the same and everything's the same, and you're still going to hear laundry because it's not done. So we are on page 13 in our geometry book, and we're moving forward in section 2-1. So 2-1 is something that deals with another piece of the geometry language puzzle, and it talks about reasoning. And found my highlighter. As we take a look at this concept of reasoning, inductive reasoning is the process of observing data, recognizing patterns, and making a generalization. So talking about making a prediction. Something that you could think about in nature. We've all had this experience where you see lightning and then you predict based on the patterns you've seen in your lifetime that shortly thereafter you will likely hear thunder. And sometimes you don't. I've been in storms where you see the lightning and you don't hear the thunder. So in that situation, you're observing what's going on around you, you're recognizing a pattern that holds, and you're trying to make a prediction so that you can process that in your brain and maybe help others along the way. This type of a generalization is called a conjecture. Okay, so we're going to take a look at some different examples. I'm actually going to skip down to number 2. We will come back to number 1, but I want you guys to take a look at this set of examples of inductive reasoning. So inductive reasoning, we're going to look for a pattern. We're going to make a generalization and see if it fits. So kind of like look at a pattern, try to think what the next step would be, check it and see if the pattern holds. It's all about making predictions. So when I look at number 2A, A, 4, C, 8, etc. You guys can read, I can read. I don't need to do that for you. I wish we were in person, because then I'd be like, what do you guys see? What are the patterns? I'm hoping that we see that we're alternating letters. So letter, number, letter, number, letter, number, letter, number. I think that's going to be a letter, and I think that's going to be a number. That's what the pattern is showing me. So now I want to try to make a generalization. Well, what's going on with these letters? A, C, E. Well, they're kind of in alphabetical order. Maybe if in place of the number, I just went in order. A, B, C, D, E, F, G, H, I. So it's skipping the next letter. I think that pattern holds. If we look at the numbers, 4, 8, 12, 16, I kind of think that the next one should be 20. So when we explain the pattern, the first thing we noticed was alternating letter number. The second thing we noticed is that we skip a letter. So A, skip B, C, skip D. And the third thing that we noticed is that the numbers increase by 4. I think that makes sense. Okay, let's try number 2. So with respect to number 2, I see only numbers. It starts with a 3. Oh, they're all odd. Okay. And then 9. So from 3 to 9, you could add 6. But if I added 6 to 9, I'm not going to get 27. So adding 6 doesn't work. And again, this is where I'm like, come on guys, do you see a pattern? I'm hoping that you guys can see that we are multiplying by 3. Oops, there should be a y in the word by. 3 times 3 makes 9, times 3 makes 27. 27 times 3 is 81. 81 times 3 is 243. I am not going to multiply that in my head. Why should I? We have calculators, so I'm literally grabbing my cell phone. 243 times 3 is 729. And then 729 times 3, if I typed correctly, is 2,187. I think that pattern holds. So again, we observed the pattern, we recognized it, we made a prediction, and it seems to be fitting. So let's try this one. So from 3 to 8, I could add 5, but 8 plus 5 is not 15. 15 plus 5 is not 24. Again, I wish I could have you guys give me some predictions. Okay, what if I multiplied? Well, 3 times 2 is 6, and 3 times 3 is 9. So that's not going to work. Let's take a look at the difference. What's the difference between 8 and 3? That's 5. What's the difference between 8 and 15? Well, 15 minus 8 is 7. What about 24 minus 15? That's 9. 35 minus 24 is 11. 48 minus 35, that's 13. Is there a pattern in the difference? Yeah. They're odd, and they go up by 2. So if we were to take the difference, we start at 5 and then add 2 more for each value. That kind of works. The difference just keeps growing by 2. So from 48 to the next number, that would be 15. Well, 48 plus 15, that's 63. So then the next difference has to be 17. Keep adding 2 by the differences. 63 plus 17 is 80. Now that one wasn't as easy to see. And here's going to be the struggle. Some of you are going to see it like that. It's just going to be like, ping, I see it, I can write it, I can predict it, I can do it. Others of us are going to be looking at that like, I didn't see that. How would I have known that? Guess and check, trial and error, give it a shot, and ask questions. It's okay. People notice certain patterns and don't notice others. Talk to people. You'll figure it out. So let's take a look at part D. From 1 to 1 is no change. From 1 to 2, 2 to 3, 3 to 5, 5 to 8, 8 to 13. Now there's a couple different ways people notice this pattern. If they ignore the very first one, we could see that the difference from 1 to 2 is 1, 2 to 3 is 1, 3 to 5 is 2, 5 to 8, the difference is 3, 8 to 13, we're going up by 5. Well, it's not consistent. What about this? What if we add the previous numbers? 1 plus 1 makes 2, and then 1 plus 2 makes 3, and 2 plus 3 makes 5, and 3 plus 5 makes 8, and 5 plus 8 makes 13. So if we add the previous 2 values, so 8 plus 13, that's 21. Interesting. And then 21 plus 13, those two, that's 34. And here's, I hope you guys were able to see that. Here is a little hint. This is called a Fibonacci series or sequence. Okay, let's go back up to number 1. So number 1's a little different. Number 1 is looking at some information and asking you, based on what you've read, what can you predict? So 5 students attended a party and ate a variety of foods. Something caused some of them to become ill, so somebody got some food poisoning. JT ate a hamburger, pasta salad, and coleslaw. Okay, so JT, hamburger, pasta salad, and coleslaw. She became ill. So I'm going to circle her name because she's sick. Guy ate coleslaw, pasta salad, but no burger. He became sick. Dean ate only the hamburger, and he's fine. Judy didn't eat anything at all. She's also fine, because if you don't eat anything, you can get food poisoning from the party. Cheryl ate a hamburger and pasta salad, and she became ill. Use inductive reasoning to make a conjecture about which food caused the illness. Well, which food did all three of the people who became ill eat? I'm going to believe that would be the pasta salad. And you might be thinking, well, what do I write down? Like, how do I show my work? You can show your work in a table. It's a pasta salad is the one thing they all ate. All right, let's turn the page. We are actually not going to address these pages, like this whole piece right here on this page. Let's see. So let's take a look, and I'm just kind of debating if we think we have enough. Let's do a little bit more. Let's look at number 5 on page 15. Again, my goal is to try to keep this video down to 15 minutes. If you need to take a break, I'm never going to know. Go take a break, come back, and finish. So the diagram on number 5 shows the first 3 figures in a pattern. Mario conjectures, so Mario predicts, that the 4th figure in the pattern will be the 3rd figure rotated 90 degrees clockwise. So let's talk about some language. I'm thinking we can agree that we have 2 sides here in this triangle. So 2 baby triangles make the big triangle, and one of them is turquoise. And this thing is turning. So if I turn my book, that first picture now matches the second picture. So it's a turn. When we talk about turns in geometry, we're going to talk about that as a rotation. So I'm going to very quickly define rotation as a turn. And the direction in which I'm turning this, okay, well, if I were to turn my book once 90 degrees and then twice another 90 degrees, that matches the 3rd picture. So this rotation is happening at 90 degrees. Okay, well, this is kind of making sense. So Mario's thinking that if I take this and I turn it 90 degrees in that same direction, that's what we'll end up with. Well, the direction we're going, if you think about a clock, and so we have, you might hear my husband in the background. He just started laughing. I'm not sure why. I wonder what the dog did. You'll see a clock. And as our clock moves and the hands rotate, we call that clockwise. So 90 degrees clockwise, I do believe that that is a good conjecture, because that looks like what's happening, and we can turn our page and see it. We're going to do number 6 real quick. Anya is training for a 10-kilometer race. That's a long race. The table shows the distance she ran during the first 3 weeks of training. So if any of you guys have ever done Bloomsday, oh boy, how long is Bloomsday? Is that a 7K? I don't know. I don't do Bloomsday. My husband and boys, they'll do Bloomsday. I wait for them and I have a donut. That's my way of doing Bloomsday. You should try it. It's awesome. So make a conjecture about the distance Anya will run during each practice of the 4th week. Well, in week 1, she did half a mile, even though it's a 10K race, but okay. Week 2, 1 mile. Week 3, 2 miles. Can you guys see a pattern? She's not increasing by half a mile, because then week 3 would be 1.5. Can we agree she's doubling it? So I think she's going to double her distance each week. How would you test your conjecture? Well, I guess you could watch her, or you could ask her, but I'm not sure that this Anya is a real person. So, we could wait and have her document, or we could say, I think in the next one, she'll do 4, and walk away because this problem is done. Alrighty, we're going to turn the page. We will take a look at just a couple of things here on this page. This is where you guys are going to be getting the assignment. It will be in Google Classroom. Please always, always, always make sure that you let me know how I can help you, and make sure you're clicking turned in so that I get that via Google Classroom. Alrighty, we're done. Bye.